Welcome back to the section number 6. This one is all about the navigation of characters. We'll look into the NavMesh surfaces and NavMesh agents, which are the way to give our non-player controlled characters a special awareness, so that they can move around the level. We'll add an enemy, and we'll make them able to attack us when they're close enough to us. And then we'll look into the animator component and the animations, so that we can visually give the motion to our enemies, move their limbs, and make them look lifelike. Without further ado, let's begin. Welcome back. In this lesson, we'll add enemies as placeholders, and we'll make them follow our character using the navigation system of Unity. This thing consists of two very important parts, the agents and the surfaces. Agents are the scripts that will help our monsters traverse the surfaces. And to bake the surfaces, we have to create an empty game object, call it NavMesh surface, for example, and onto it add a NavMesh surface component. If you don't see it, then simply stick the NavMesh agent and install the navigation package from here. Remove the NavMesh agent and install the NavMesh surface. If I click Bake, you'll see that it considers all of the meshes in our scene and figures out the places where the enemies will be able to walk. You can see that this surface is designed for the humanoid characters, which will mean that it will consider their radius when looking at the objects and when creating the passages. If you don't want to consider all of the game objects, you might want to pick, for example, the physics colliders, and when I bake, it will only consider the decoration colliders in this case. Will not consider the meshes. Because this box has a collider, it does get considered, but the surfaces that haven't got the colliders, they are skipped, and the surface only considers the walls and so on. Careful, because this will make surfaces allow the enemies to walk right through the objects. We can also take the decoration colliders, for example, and make them the children objects of the NavMesh surface. And in this case, we can then pick not all the game objects, but only the current object hierarchy. So when we bake those objects, it will only consider the children of this NavMesh surface when computing these areas. You can also filter out by layers of the game objects. So for example, if you take the decorations colliders, the floor colliders, for instance, you can set the layers here and add a layer if you need to. But you can only have up to 32 of those. Those things are more powerful than the tags, because Unity is looking at the layers when optimizing the game, and using layers you can also filter out which objects do collide with each other in physics and which ones don't collide. So layers is pretty powerful, and the NavMesh surfaces are also able to filter out the objects by layers as well. But in this case, I'm going to pick everything. So the current object hierarchy, all the layers for the humanoid. If I go here, I can also make this surface work for another type of the character. For example, in the agents, I can add another agent, rename it to a larger agent, make it radius, for example, 1. And now if I use that one instead of the humanoid, and when I do bake, you'll see that the passages will become slimmer because it has to consider the radius of this larger character for which the surface is designed. This one has a radius of 1, so it does make the passages smaller. Let's collapse this, and here create NavMesh agents, under which we'll create an enemy. On here add the NavMesh agent. I'll make it the larger agent, because that's what my surface was baked for. You can control its parameters here, like the rotation speed and the movement speed, or how much distance has to remain between it and the target when it decides to stop bothering to move. And additional parameters that are not really considered by the surface, but can help in the local avoidance scenarios, when there are various characters and they have to figure out who avoids whom. Lower priority characters will walk straight through other characters, but the high priority will try to avoid the characters whose priority is closer to 1. Let's take our enemy and bring them somewhere here, into the red room, and onto it I would like to attach a script, enemy. In the enemy I'll create 2 slots. The transform to follow, and also a slot for our NavMesh agent script that will be attached on the same game object as this enemy script. You can see that we have to include this dependency for this thing to be recognized. And every single update by our enemy script, we're going to take myNavAgent and do set destination on it. It requires a vector3 coordinate, so we can do new vector3, or actually we can take the transform to follow and access its position, because the position is readable and settable, and it's of type vector3, just exactly what this thing requires. So I'll take position and stick it as an input into this method. This will happen every single frame, so our NavMesh agent will recompute its paths along the surfaces every frame in order to reach the target. So before we hit play, let's also take the transform which it will try to follow. In this case, let's do the player. So it's going to be the transform of the player. And the NavMesh agent of this enemy script is going to be on the same game object as this script is attached. So we have the enemy here, our character here, and if I switch into the game view, hit the play, you'll see that this character will start to chase the transform that it's meant to follow. So we can't really see it, so we'll need to add some kind of mesh to actually see our enemy. On here, I'll add mesh filter and provide some collection of vertices, for example, this cylinder. But also I'll add a mesh renderer to make it visible. And on it, stick any kind of material that works, for example, this one. And as you can see, the game object's placement is here, but the NavMesh agent is kind of from here upwards. So we gotta adjust the base offset, prevent the character from drowning, and plop it here. Now we're able to see the character, the enemy, who'll be trying to reach our transform's position. And the thing is, it's able to walk right through the doors. That is because its surfaces, when they were baked, they didn't consider those doors. Because those objects are dynamic, they might open at some point in the game, and it might not be very feasible to rebake the surfaces each time. So in that case, we'll stop the game, take our door, specifically its meshes, this one and also this one, and on them I'll add a NavMesh obstacle. Those are the things that will be dynamically carving out the surfaces beneath them. I'll give them the shape of the box. And I'll tick the carve checkbox. When I hit play, we can see that the enemy who is locked in that room, it wants to follow our transform right here, but it can't walk because the surface is currently carved. If I take the door hinge, for example, and open it up, you'll see that the surface will be recomputed at some point. Even though there is a small area here, remember that our agent is of the larger type, so it has a very thick radius. This means there is not enough space here, so I'm going to open both the doors with their obstacles, and then the surface becomes traversable because the obstacle changes position and stops the carving operation in that location, which is just sufficient enough for the object to be squeezed through. So because the agent is so large, its radius is 1, it might make sense to make the agent have a larger radius here and also increase the geometry radius. But to do that, we'll have to adjust the scale, which might not be very good since that can confuse the NavMesh agent. If we want to change the scale, then we'll have to move our geometry to a child object and modify the scale of the child game object instead. Because for cleanness, we want to keep the scale 111, at least on the game object which contains the NavMesh agent. I'm not going to be tinkering with it here. So we've learned about the surfaces and the agents. In the next lesson, I'd like to show you how to follow the player around only when they're close enough to the enemy. We'll do this through the special colliders by making them triggers, which will allow them to sense when some player's collider has entered them. I'll be waiting for you there. Let's adjust our enemy slightly so that it only starts to run after we enter its range. For this purpose, I'm going to add a large sphere collider with a rigid body onto this enemy, but it shouldn't be on the same game object as the NavMesh agent. Instead, we can add it to a child game object of the enemy. So here I'm going to create an empty game object and call it sensor. On it, I'll add a sphere collider, increase its radius to something like that, and add a rigid body, because if your object is moving around, for performance reasons, you must always add a rigid body. Otherwise, this will strain the physics system and will reduce the performance. And here, because we're moving this ourselves, it's meant to be kinematic and should not use gravity. And lastly, our sphere collider should be a trigger. This means that it will not repel other objects, but it will simply sense them entering this trigger. In the scripts, let's add a C# script, enemy sensor. And in here, I'm going to add a couple of magical methods. You already know about void on collision enter, but this one is going to be on trigger enter. So when something enters our collider, who is really a trigger. You can see that we're able to figure out what has entered us because we're given this as an input. So we're going to declare a variable here, public bool is player nearby, set it to false by default. And when something enters us, we're going to check if other.gameObject.tag is exactly equal to player. Then, because it entered us, we're going to say is player nearby becomes equal to true. And similarly for the void on trigger exit, if the game object of the entered collider, which is other game object.tag is also a player, because it's exited us, we're going to say is player nearby becomes equal to false. And this way, anybody who has a reference to this enemy sensor, they are able to access our variable and see if the player is nearby currently or not. So in the enemy script, let's make a slot for the script and only rebuild the destination towards the player if the player is nearby. So if my enemy sensor dot is player nearby, then we're going to be setting the destination to follow the transform of our player. Otherwise, if this is false, we're going to keep the previous destination. Or even we can do else my NavMesh agent dot reset path, which means that it will discard its path and will stop trying to reach the previous destination. So here on the sensor, let's add the enemy sensor. And on the enemy, let's link up the sensor from here into the slot for the enemy sensor. So now the enemy will be constantly querying its sensor who has this fear trigger. Do you see the player? Do you see the player? And when it does see the player, the enemy will try to build the path to the player transform. Effectively, this makes our monster only respond to the player once we have reached and approached it sufficiently close enough. But one thing is, our player currently is moving around, but we are looking for the tag. And right now the player is currently marked with the main camera. Instead, I'm going to create a new tag, or I already have it here, the player. And also, it's important that our game object, who has the tag player, also has the capsule collider and also has the rigid body component attached on it. Because if we have the player with the player tag, but its capsule collider and rigid body are on some child game objects here, the sensor will detect the colliders of those child objects, but they themselves will not necessarily have the player tag. So the player does have a tag, and it also has the capsule and the rigid body colliders. The sensor will be able to feel those and confirm that they have the player tag. So let's take this and approach our monster, and you can see as soon as I walk close to it, it will start to approach us as well and walk towards us. And you can see that this obstacle here, that is on this door and this one, it currently has the carve as off, but the character is still using local avoidance and is not able to pass through it. So it's slamming through the door trying to get through, but local avoidance is preventing it from doing it. If I take those obstacles and set them to carve, then the enemy's path will take this into the account. If I untick it, then the character will consider that there is a passage, but will always be surprised that there is some obstacle in front of it. So it's more performant this way if you don't carve, but the characters will be quite surprised when there is something in front of them, preventing them from passing through the doors. For our purposes, it's sufficient. We can take the crate and help the monster to get out from the door. And you can see that it goes right through towards us because we are within its range. And as soon as we run away, it will lose ourselves and will reset its path and will prevent trying to access us until we approach its sensor once again. In the next lesson, we'll add the enemy state, the attacking, so I'll be waiting for you there. For this lesson, let's add an ability to defeat our enemy so that we can remove it and despawn it from the game. In this case, for the enemy script, I'm going to add a variable and I'll make it private integer. This means that if somebody is holding a reference to my script and tries to read the variables, they'll never be able to access this thing because it's private and it's only accessible from within the script. Nobody else will see it. By default, let's make health equal to 3, and let's also add a function subtract health. I'll make it public so that everybody who is holding the reference to my script is able to see this method and invoke it. Let's require as an input the amount that we need to subtract. For example, 1. We'll take our health and we'll reduce it by the subtracted amount. So minus equals the subtracted amount. We can also do health becomes equal to current health minus the subtracted amount. So we're subtracting, getting a number, and assigning it back to health. But minus equals is faster this way. We'll reduce our health. And in here, let's also check if health is 0. We're going to go ahead and destroy the game object onto which this enemy script is attached. So this .gameObject, let's pass it into a method called destroy. It will get rid of this script of the game object and everything that is attached to the enemy. Now we have this subtract health mechanism in the enemy, but we need to trigger it somehow. I want my character to be able to click on the enemy, just like we clicked on the crate. And if we clicked on the enemy, we're going to reduce their health by 1, simulating the attacking. So I'm going to create a script, player attack enemy. Take it and also let's position the grab object script from before, because we're going to copy most of its code. So we're going to take this, and in the player attack enemy, I'm going to paste this update function. So if the player has pressed the left mouse button, we're going to invoke some mechanism, for example this one, but I'm just going to change its name to attack enemy. Change it here and change here as well. I won't need this probably because I'm not dealing with rigid bodies. And in the attack enemy, check if I have intersected with some collider. If I have not, then I just early return and don't proceed to the rest within this method. But if I did intersect, then I'm starting to work through those lines. So here we're going to say is enemy. If the game object of the transform of the collider that we've hit, if its tag is enemy, then this is going to be true, and we'll assign the result into is enemy. So if is enemy is true, then we'll do this thing. And in here, we want to access this information variable that was filled for us by this physics raycast. Take it and access its transform.gameObject, and we cannot access the enemy script because it's not very popular and Unity doesn't know about it, but instead we can search for it on this game object by doing getComponent, and the type of the script that we're looking for is the enemy. And if we found it, we can see that it will return us a reference to the enemy component or script. Let's take the result of this and assign it into an enemy found enemy variable. So this gets assigned into here. And let's see if the enemy is null. That means we were not able to find such a script on this game object with which our array has intersected. Not able to find, so we're just going to return. Otherwise, found the enemy script. Let's take the found enemy. And remember that we have this function subtract health that we've created and which is public. So we're able to see it from other script like this one. So we can do dot and let's say please run this mechanism called subtract health. It says fine, but you need to provide me a number. How much do you want to subtract? Let's say reduce it by 1. So this thing will run, we'll be waiting for it. Once it's complete, we'll continue executing, but here our function finishes and we return back to what has invoked it. And our update finishes this way. So our player attack enemy is able to check every single frame. Have we pressed the left mouse button? If yes, attack the enemy. Here we're saying fine, let's shoot a ray from the position of the game object onto which the script is attached, forwards. Collect the information about anything that we've intersected into this hit variable. Tell us if we did intersect anything or not, because it returns Boolean. We store it here. If we did not intersect, return. Otherwise, check if what we've intersected with is the enemy. If it is enemy, and is not stuff like the crate or the walls, if it's enemy, then we're gonna try to find the script on the same game object where the collider with whom we've intersected is. And if we did find the enemy script, then we can say that particular script subtract its health by 1. And that particular script will go ahead and subtract, and in the meantime we'll also check if it's supposed to destroy itself and its actual game object. Remember what I told in the previous lesson, that if you have a NavMesh agent on your enemy, any kind of colliders or rigid bodies, they're supposed to be on the child game object. We already have the sensor here. The sensor is a trigger, so our player's ray will not be able to intersect with it. We need to create another sibling game object, so I'm going to create it collider. And this one is also going to have a rigid body and will also have, in this case, capsule collider. But this one will not be a trigger because it's not a sensor. It's meant to repel objects and meant to be detected by our raycast. So I'm going to keep it not trigger. I'm going to make sure we have rigid body here, and let's set it to kinematic and disable the gravity, because this thing will be moving through the script and actually will be following our enemy that will be moving around. So make sure the collider is kinematic. Let's verify that the sensor is also kinematic. Yes, it is. Both are not using the gravity, so that's fine. And last thing is, when we shoot a ray from our player and we do intersect with the capsule collider of the enemy, it will say, okay, cool, intersection has occurred. Now is the tag of your game object equal to player? And currently it's untagged, so there will be an issue. Let's make it the enemy. We haven't got it here, so add a tag, add a new tag, enemy. And back on the collider, let's make sure that it's enemy. Our code here will say, cool, you're enemy, so I'm going to try to find a script on your game object. The script that I'll be searching is the enemy. But if we look here, we haven't got an enemy script. It is somewhere on the parent game object. So instead of doing getComponent on here, let's say getComponent in parent. So we are searching for the script on this game object and also on all the parents until we find it. And once we've clicked on our enemy, it will be subtracting its health. Once we've clicked sufficient amount of times, the enemy is meant to disappear. It will feel us, so it will start to run towards us. When we click on it 1, 2, and 3, it's meant to disappear, but it does not. And that's because our player, the camera, it has the player look, the player grab object, but doesn't have currently the player attack enemy. So on this camera game object, I'm going to add player attack enemy script. And also while we're at it, let's take our enemy and increase its stopping distance to 2. So it will not try to slam into our player, but will stop moving towards it once it's within the 2 meters next to the player. Clicking on the enemy, 1, 2, and 3, we can see that its health was reduced, and it decided that its health is 0, so better destroy itself along with its game object. And it disappeared. For now, that's sufficient. We're able to defeat the enemy. In the next video, we'll add the ability for the enemy to do the similar thing but to the player, to attack them every 5 seconds until the health is depleted and the scene needs to be restarted. So now let's add the ability for the monster to defeat ourselves. When it's nearby of the player, it will ask it to reduce its health by 1, and the player, when it notices that the health is 0, it will not destroy itself, but will just ask the scene to be reloaded. Let's do this now. So we've got our player. It has the player movement. It also has the camera with a couple of components like the looking, the grabbing of objects, and the one that attacks the enemy. But it would be good to add a new component that keeps track of the health. So here I'm going to attach a new script that I'm going to create in the scripts folder. For example, player. And on my player, I'm going to add the player script. Make sure the game is stopped when you do this, and drag the player onto the player game object. So in here, let's add a private int health, so nobody else is able to see it apart from us. We'll make it 3 by default, and we'll add a method that will be able to be visible to anyone who references us, public void subtract health, just like we did on the enemy. Let's take our health and subtract the needed amount that must be passed to us when somebody invokes this method. And if our health is equal to 0, then we're going to ask the dungeon scene to be reloaded. If you remember, we've got a UI manager that is able to show the game over screen, and also the game manager, which is able to reload the scenes. So in here in the player, I'm going to add a couple of slots, public UI manager, and also game manager. If our health is 0, we're going to ask the UI manager to show the game over screen. And this function currently doesn't exist, so let's jump into our UI manager and add it here. So if you remember, we were triggering the game over screen using this thing. We're going to take the game over geo and set it as active true when somebody is asking us to show the game over screen. Let's also take a boolean is show, because somebody might want to invoke this method with a false, and we'll simply hide the game over screen like that. In our player, show game over screen now requires a boolean input, so let's say true because our health was reduced. And let's also ask the game manager to load the scene. So the reload current scene is here, but it's not public, so nobody's able to access it. Let's make it as public. And now our player, when it takes this game manager, it's going to be able to see it. Reload the current scene. So now our player has this method for subtracting our own health, but the enemy currently doesn't care about it, will not try to do anything, so let's make sure that it tries to attack us. If my enemy sensor is player nearby, we'll go ahead and subtract the player's health, but we currently haven't got any reference to the player. We don't know how to access the script. It would be good if our sensor not only would tell us if the player is nearby or not, but would also keep a reference to this player. So player, nearby player. During the enter and exit, if the entered tag is the player, not only do we set this to the player is true, but we also try to find and establish the reference for our variable here. So our nearby player becomes equal to other.gameObject.getComponent, perhaps in parent, in case if the collider is attached not directly on the player. So getComponent in parent, player, and just like that, we're also going to be grabbing and establishing reference to the nearby player. And here, when they've exited, the nearby player becomes equal to null. So now the enemy, when it's in the update and it knows that the player is nearby, we can also check if the enemy sensor dot nearby player is not null. Then we're able to access the nearby player within the sensor and affect our player's health. So I'm going to say subtract health. I'm going to reduce it by an integer of 1. And this will happen every single frame, so very quickly it will kill our player unless we introduce some kind of delay. Private decimal number, so float, previous attack time. Let's make it negative so that our first attack can happen almost immediately. And here, we're only going to do this if enough time has passed since the previous attack. So if the current time, is greater than the previous attack time plus 5 seconds. So has 5 seconds elapsed since the previous attack time. If the current time has already exceeded that, is greater than the previous plus 5, then we can go ahead and subtract the player's health. And also in the player, every single update, let's go ahead and ask our UI manager to show the correct amount of hearts. So UI manager, show health, and let's pass our current health. This way our enemy is supposed to be attacking our player every 5 seconds, and our player will be constantly notifying the UI manager about the health. Once the health reaches 0, it will ask to show the game over screen and reload the current scene. Let's also make sure that our player knows about the UI manager and the game manager. So I'm going to click on the circle here and find the only manager that we have in the scene and the game manager as well. Those are those two game objects. Trying to enter the room with the monster, we can see it kills us almost immediately because when our enemy attacks the player and enough time has passed since the previous attack, we are reducing the health, but we also need to make sure to remember the current time as the previous attack time. So we perform the attack and make sure to remember the time so that the next delay is being counted from now onwards during the next frames. 1, 2, and 3. And it kills us and the game is over. And the scene was reloaded and everything was restarted. You can see the enemy is here and the player is returned back to his original position. Now you've learned about referencing different scripts. Our enemy is able to attack us every 5 seconds until the health is depleted and the player script realizes that it needs to reload the current scene. Next we'll start to add interesting meshes for our enemies and we'll animate them. So I'll see you in the next lesson. Hello. In this lesson we'll be looking at the animations of our characters, specifically the animations of the enemy. Because right now we have got a capsule and I'd like to improve its overall look so that we have something interesting. For this purpose I'm going to be using the Dog Knight character. We can see that it has some basic animations, like the idle animation, the attacking animation, the second attacking animation, and also getting hit and dying. So we'll use all of those animations to make our game more interesting. And we can add it to Unity and open it there. And the important thing is that it contains various animations here in the description and is also fully compatible with Mechanim Humanoid. This means that you'll be able to reuse the animations from other characters, as long as they also support Mechanim Humanoid. It basically means that its skeleton has a specific structure, so animations from one skeleton can be applied to the skeleton of this character as well. So in the project I've got the PBR and the poly art variant of the prefabs for this Dog Knight. If I drag one of them, we can see that it's pink. That's because it's made for the default standard pipeline, which is less optimized than our current one, URP. So in this case I'm going to click on it until I get to the skinned mesh renderer, which contains the collection of vertices, but also the material. And we can see that it's using an algorithm, the shader, for the standard rendering pipeline. So I'm going to click here and pick the one for our current, so universal rendering pipeline. Let's pick the lit, making it visible. If I scroll down here, I can see that certain textures are currently being populated, giving us this kind of look, but the albedo texture has to be reconnected into the base map slot. So this will be our enemy. Let's take the capsule, the enemy. We see that it has the NavMesh agent and the enemy script, but also has the cylinder, which I'm going to remove, the mesh filter and mesh renderer, and make the dog PBR the child of the enemy. So we can see the enemy has the sensor, the collider, and now also the dock PBR model. In this case, let's give it a local offset of 0 so that it's completely centered inside of our enemy thing. Dock PBR I'm gonna lower down, carefully increase the height by scaling it up uniformly from the center upwards. And it's important that the scale matches on all 3 numbers, so it's uniform. Let's do 1.5, 1.5 and 1.5 here. So if we go into the local mode, we can see that it's facing forward this direction, which must match the forward direction of our enemy, which is also in this direction. Once again, if we look at the dog PBR, we can see that it's an empty game object with a single transform, which we can reposition. And it has one important component that we'll be talking about today, the animator. The animator is what's going to be driving the meshes, the geometry, that is its children, to distort and deform it. The animator is basically like a graph, a collection of animations, of motion clips, between which we can blend and transition to give the appearance of our character moving around. And if I click on it, we can see that the poly surface actually contains the collection of vertices that describe this character, but also there is next to it a collection of game objects, which are just simply empty containers, empty game objects, with just a transform. So for example, the spine right here is a transform, but the cool thing is, because it's being used by this skin mesh renderer here, if I take this spine and rotate it around, you can see that the character distorts and deforms. Those things on the dog PBR, the animator, it will work together with the skinned mesh renderer and its skeleton, and will animate the skeleton according to this avatar. The avatar is simply a description of the skeleton to help the animator understand how the skeleton is structured. And if we click here, we can see it's part of this mesh FBX model that is part of the spec. So if I click on it, I can configure the avatar, and I can see, if I zoom out from here, that it's a mesh and also a skeleton within the mesh. This way, if I click here on the pelvis, we can see that this bone is currently being linked to be used by this part here. And if I click here on the knee, we see that this bone is responsible for this portion here, and it will be deforming this section. So this way, in this default position, the T-pose, so-called, we're able to specify which bone maps where, so that Unity is able to say, all right, I want to, for example, take the spine and rotate it. Where is your spine? And this way we told it that the spine is right here. So if it animates the spine, it will be affecting this particular bone. That's the avatar, and specifically that's the humanoid avatar, very popular one. But if your character is more advanced than that, perhaps it has like 4 legs or something, then you won't be able to use the humanoid, and you'll have to use a custom avatar and the custom animations. But as long as your model has the humanoid avatar, you'll be able to reuse a vast amount of different high-quality animations recorded by humans, because the bone structure is very similar. So I'm going to Control Z everything here. You'll be able to drag and drop the bones if you need to remap them, but this right now is good for me. So Control Z everything and exit the avatar configuration, revert because everything was good. We can see that once again there is this animator with the avatar, the structure of the bones, but the controller is what contains the graph of animations. It's the animation controller. And if I click here, the person who supplied us the spec already has offered us the animator controller. If I click here, this thing opens up the animator window. We can also go into the window, animation, and animator, if you need to open this window. And here you can use the scroll wheel to zoom in and out, as well as middle mouse and drag. But we can see that it has several animation clips and various transitions between them. For example, we can see that the character will always begin from the idle battle animation clip. And depending on various conditions, it will be able to transition either into attack, and from there into attack 2 and defend and get hit, or somewhere else. But if I take this one and drag it out, we can see that the graph follows kind of like this pattern, which means that we're not able to enter the run forward battle from the idle battle, because currently the only way to do it is to follow the direction of arrows. So we can go this way, enter the animation, and then eventually we'll come back to idle battle. That's good for showcasing the character, but isn't very good for animating it within the game, because I would want to transition to run forward, or to attack, or to defend at my will, and currently this graph doesn't allow it. It's also important to recognize that this graph is currently located on the base layer, and you might have multiple layers. So if you go ahead and click here, you can create a second layer, for example upper body, and if your base layer contains some kind of running animations, the upper body, if you have an appropriate mask for the upper portion of the body, this layer will allow you to use the animations specifically tailored for attacking and affecting just the upper body. Once again, as long as your mask is correct. So you can specify the mask here, which is going to ensure that the animations in the upper body layer will only animate the skeleton bones that are permitted by this mask. I want to click on the upper body, right click and delete it. We have the layers currently here, but also the parameters, which are the variables, for example booleans, or the decimal numbers, which we'll use to see if we're able to move from here into another clip and start doing something with our character. So the parameters will be very important. We can click here and add a decimal number, a whole number like -1, 2, 3, and so on. Boolean, either true or false, or the trigger, which is a one-shot boolean, meaning that if it becomes true, as soon as it's used up, for example for transitioning, the trigger will be automatically reset back to false. If I click on the state, for example the idle battle, we can see it's described here. It contains one single animation clip, which actually contains the keyframes and various curves that define the motion. I can also click, for example, on the attack 2, and we can see it's basically the same thing, but they have their own animation clip, which is played at the speed of 120%. And each one, for example, the attack 2 or the defend, it only has one transition. So on the defend, we can see there is one single transition from defend to get hit. And if I click on the get hit, we have one transition here from get hit to dizzy. So meaning this particular transition right here to dizzy. We can click on the arrow and see that it's describing us how it's going to be blending between the get hit and dizzy. With this blue arrow selected, we can check here and see how the blending is happening. So now that we've looked at the animation controller, which is attached inside of the animator component, we've looked at the avatar and the structure of the skeleton. In the next video, we're going to adjust the states in the animation controller's graph and trigger the transitions to actually affect our character and make them do something. Welcome back. In this video, we're going to be affecting the animator component through the scripts. So let's take our enemy, right-click on the script and edit it. And for it, I would want to create a new slot, the animator slot. Let's create a public animator. I'll call it animator within this script. And in the update, if my NavMesh agent has a path, in that case, it means that it's moving. So I'm going to take my animator component and tell it to start running. Set Boolean. The second option will allow us to specify the name of the property is running, and let's make it true. So if we have the path, we're going to set is running to true. Otherwise, we're going to do the same thing, but set the Boolean for is running to false. Let's save the script. We've got the slot here, so I'm going to take the game object, which contains the animator, this one, and drag it into the slot. If I click on this thing, we can see that the animator contains the controller, which will have this parameter is running, as long as we specify it, of course. So I'm going to click here to highlight it in the project, and I'm going to double click on the dock control. Let's take this and disconnect the transition so that we're not transitioning from the idle anywhere, and also this thing. So we'll be restructuring the whole thing. By default, we'll always be in this animation state, but we need to add a parameter, the is running parameter. So let's go and in the parameters here, click Boolean, and say is running. The capitalization is important, so let's see, I is lowercase here. In our script, it must be also lowercase. So I'm going to do is running here like that. And now let's find a state which contains the running animation. So walk forward, run forward. Let's do run forward in this case. I'm actually going to take it and press Ctrl D to duplicate it. And then we have this state which contains the animation clip run forward battle, which is going to be played at this speed. So let's right-click on the idle battle and make a transition from it to the run forward battle. If we click on this transition, we're going to see that it contains a blend between the idle animation and the running animation. We can play here to test it, so you can see it's being animated, and it starts running. So to trigger this transition, this arrow, and to start going from here to here, we need to specify the condition. So we're only going to start transitioning once the is running is true. I've clicked on this plus button, and I can see that there is one condition, the is running. That's the only variable that we currently have, so I'm going to pick it from here. It must be true for this thing to start going. And if you have multiple things that you want to check, for example, a second Boolean, then you can click on the plus here and specify your another Boolean here. And the transition will only start going as long as both of those Booleans are satisfied. So for example, if is running is true and my other Boolean, for example, is false. Only if this condition is true, so this is true and this is false, only then will the transition start going. But in my case, I don't need it, so I'm going to click here and press on the minus. And also, for me, it's important that the animation starts transitioning as soon as the condition is true. So I'm going to untick the has exit time, otherwise would be forced to wait for the current animation to complete its playing, and then start transitioning. If the condition is true, we don't care whether the current idle animation clip has fully played, we're just going to transition straight away. So I've unticked this thing, and in the settings we can specify how long does it take to transition from one animation into another. So we can see that the fixed duration is ticked, meaning that the transition is specified in the seconds. So a quarter of a second here, and let's say that the transition is not as important as the next transition if we decide to suddenly transition to another clip while still transitioning. So I'm going to pick next state, then the current state. So this looks good. Our character is able to transition from here into the run forward battle, but once it's here, it will be forever stuck in this state, even if it no longer wants to run. So in this case, right click on the run forward battle, make transition, and click on the idle battle. And then on this new arrow, if we click here, we can specify that we want to transition from run into the idle battle, so from run to the idle, only if the condition, our is running, is false. So as soon as it's false, we're going to start transitioning, but of course we need to make sure that we don't wait for the current running animation, for the current clip to finish playing, so I'm going to untick this, and we're going to start using this arrow while being in this state as soon as our condition is true. These things here are fine. Maybe let's make sure that our transition is not as important as some other transition. I'm going to say next state than the current state. And here everything looks good. The duration to switch from this state into another is sufficient, 1/4 of a second. So I'm going to collapse this thing. We have the conditions, we have our variable here, and we're going to be able to run and become idle very quickly. Let's save everything. We've got this graph, which is encoded in this asset, plugged into the animator right here. And this whole script is being referenced by the enemy because we've plugged its animator component into here. So our script is saying, as soon as our character has a path and is navigating through the blue surface, then we're going to set is running to true. And the naming is important, so we've correctly specified the letters. Otherwise, we're going to stop running. Also, down here, let's say if we're attacking, then let's do the animator.setBoolean is attack to true. In the next video, I want to code up the triggering of the attack animation. And because we have 2 animation clips, we're going to use the random one. In there, we'll actually test our animations and see them working. Welcome back. This time, let's add the attacking animation onto our character and actually confirm that the clips are playing on our 3D geometry. Let's take the isAttack, and because we have 2 animation clips, I want to play one of them randomly. So we're going to play either first or second. In this case, let's use the setInteger, attack number, and give it a number. Of course, we have to create it up here. And to it, I'm going to assign the result of random.range, which is the mechanism, the method that we saw in the previous lessons. It's able to return us a decimal number if we give it 2 decimal numbers, or it's able to give us the whole number between the whole numbers that we give it. But be careful because this one is exclusive. So if I specify, for example, 0 and 100, the maximum number that it will be able to give us will be 99. So I want to do between 1 and 3, meaning it's able to return us 1 or 2. We take this thing and assign it into the integer, and if you ever wanted to specify the decimals to use the first variant, then you just put 0f here and 3.0f. But be careful because in this case, when it's returning you a decimal number, you are assigning it currently into the integer container, meaning that you'll discard the fraction and discard the decimal portion, so always assign it to float in this case. But right now I want to use integers, the whole numbers, either 1 or 2. And if that's not true, we're going to say else, the animator setInteger attack number, let's do 0. And down here, let's do also else, make sure that the attack number is 0. So we've got the attack number that we're setting in the animator. Let's make sure that our graph actually contains this property. So I'm going to click on the plus, do the integer because it's a whole number, double click here, specify attack number. And in here, I'm going to take the first attack, let's duplicate it, and also duplicate the second attack. And then from the idle battle, make transition into the attack and into here as well. And also from the run forward battle, make the transition from here and make the transition into here. Let's quickly rename them. So attack 2 to correspond to the clip that it contains, and attack 1. If we click on the blue arrow, we can specify the condition. So for example, attack number is equals to 1. And in this case, for this arrow, attack number equals to 2. I'll also do the same thing for the run forward battle. So its transitions here, I'm going to specify attack number equals to 1, and this one attack number equals to 2. Now when we're in the attack number, there is no way to exit back into the idle unless we've created a transition for it, but let's use the exit node in this case. So I'm going to right click on the attack, make a transition, and here. So we'll exit and then re-enter and start doing everything from the default state. So these transitions here, they should only exit once we've finished playing the current animation. So the has exit time must be ticked here. We want to finish the attack before exiting to the next one. And also for this arrow here as well. So now if we test our game, I'm going to take the animator and drag it down here so we see slightly better what's happening. We can see that our enemy is currently in the idle battle. its running is false and attack number is 0. Let's start to open the door and approach it. So it starts running towards us, and you can see down in the graph that the running battle animation is being played. But we can see that the attack is not being triggered. So we've got to check why it's always at 0, and we're not transitioning into the attack, even though I saw it was subtracting our health. The reason for this is it does get assigned, but immediately on the next frame it becomes equal to 0. And somewhere in our transitions here, we've forgot to probably untick the has exit time. So from our run forward battle state, we want to start transitioning into the attack when the attack number equals to 2, but also we don't care for the current running forward animation to finish playing, because we want to start transitioning as soon as this thing becomes equal to 2, because in the next frame we're going to reset it back to 0. So it's important to make sure that we start transitioning from the running as soon as we have this thing true. So untick has exit time, and here as well let's untick, and same for the idle state. We don't care for it to finish playing, we want to start transitioning as soon as this thing is true. So has exit time, let's untick it and restart the game and open up the door for this dude. You can see it starts attacking us and running, and boom, it starts attacking again, and on the third hit will be immediately destroyed and the game over screen will be shown. So this way you're able to ask your script to jump between the states via the transitions as soon as the variables have been set. And this is done by the animator component here, who controls your graph. And the animator component is being told to do so by the enemy script on this game object. Well done. In the next video we'll conclude the section and we'll discuss your next task.